Hi everybody, and welcome to another part of these Solidity tutorials. In this part we're going to create another smart contract using Openzeppelin in order to create a token without writing too many lines of codes and be able to simply mint a token. So in order to do that, we will use the Openzeppelin library one more time and use the smart contract in order to create a token in just 3 lines, and without ever needing to write a very long smart contract just like the previous videos, just like we did in Openzeppelin erc20.so. So here I'm going to create a new file and call this short erc20.so, but this is exactly the same as Openzeppelin erc20 token, but the smart contract is much simpler and smaller, actually shorter than what we had in Openzeppelin erc20.so. So just as always, I'm going to copy the first 2 lines inside the new erc20, paste it right over here, and what I'm going to do is to copy and paste this import from Openzeppelin right over here, and we're ready to write the smart contract we're looking for. So first of all, contract MyToken is erc20. So now what we're going to do is to create a constructor related to our token constructor, and it will be erc20. So first of all, parentheses and erc20, and so we'll get to properties MyToken, and which is the name of the token, so we can name it anything. I'm going to call this MyToken as the name of the token, and mtkn as the symbol of the token. So now let's open the brackets, and here we'll mint the number of tokens, so here we'll determine the total supply. So here we should enter message.sender and the number of the total supply. So you can mint any number of tokens that you like. So for example, and it also depends on the decimals, so you can write a kind of number for yourself and multiply it by 10 to the power. And by the way, in Solidity, multiplication is written this way, and this is the power, so 10 to the power of a number. Oh, okay, so then we'll have uint 256, so decimals, so we'll get the decimals from the user, and there we go. Okay, so let's add semicolon, and at the beginning of this let's add the multiplier 2. So here you can write any number, and the decimals also will be determined by you. So for example, if it is 8, 10 to the power of 8, or if it is 18, 10 to the power of 18. So it's totally up to you. And by the way, here you can write some kind of long number right over here. So for example, this could be a billion, a million, or any other number that you like. So here, for example, I determine this to be 1 billion. So 4 digits and 3 and 3. Okay, for example, 1 billion. So now I can save this. Let's see what the problem is here. So my contract, MyToken, is erc20. So what's the problem with this one? So actually here it's erc20, not IERC20, because here we'll use directly the erc20.so, not the interface of it. But in the previous one, in the Openzeppelin smart contract, we use the interface of Openzeppelin. So here we're directly using the Openzeppelin, and once we save this, we won't have this error anymore. So once we do that, as you can see, it's been compiled successfully, and now we're ready to deploy our smart contract. So as simple as this, we've written a smart contract for our token, and it will work just fine. So now it's time for deployment, and you can just simply deploy it. And then, as you can see, we have all of the options that we had inside of this smart contract once we deployed it, right? As you can remember, when we deployed this Openzeppelin ERC20, which we had written all by ourselves, then we had these options. Right now for this one, we also have these options again. So you don't have to learn all of these if you just want to create a token by yourself. But if you want to deeply learn what happened inside of our contract Openzeppelin ERC20, then you can see the previous videos. But if you have seen them, then you have already learned what is going on inside of this contract. So in most of the tutorials, the instructors won't tell you what's going on in this ERC20 Openzeppelin library, but now that I've taught you, then you know what's going on. It's not just a simple contract, and also you can customize it however you like. So now you will understand what is this approve, decrease allowance, increase allowance, transfer from, allowance, balance of decimals, name, symbol, total supply, and so on. So in case you haven't seen those videos, I'm going to explain one by one what they are. So here, if you click on the decimals, you will see that it's 18 by default, because in the ERC20.sol it has been defined to be 18, and we have no control over it. But on the Openzeppelin ERC20.sol, we had a control over it, so we could have determined the decimals at the time of deployment of the contract. We also had the control over the name and the symbol, which we had here in the code by ourselves. So here we have determined the name of the token, the symbol of it, and also total supply of the token when we call the mint function, right? But whenever you want, you can change them here, right, instead of the smart contract. But at the time when we defined this smart contract, at the time of deployment, we had this capability to do whatever we wanted. So now that we've deployed this one, let's work a little bit with its options and then go after the others. So here you can check the balances of the different addresses, also the allowance of the spender if there is any spender with this specific address, and also the approved to a specific address as a spender. So here we can determine the spender and the amount from the message sender. So for example, let me copy and paste it right over here, amount 21, for example, million. So 21 million, now it's fine. And let's get back to the initial address, because that's the only time we can do this. Now it's been done. So let's copy this address, Control A, Control C, and check the allowance of this address. So the address of the spender, also the address of the message sender, the person who is the owner of the smart contract, and then call this, as you can see, it's 21 million. So now if you check the balance of the spender, it's 0, because it's just the spender. It won't, he or she won't have any money. It just has the allowance of the spending the money. So here we can increase the allowance. So for example, I can change this to change 21 million to 22 million, which is adding 1 million, right? So here it's this. So let's actually add the spender address, copy and paste the spender address, and here we can add 1 million tokens to the allowance. And if you check the allowance, so where was it? It was here. it's now 22 million because we've added 1 million. So if I decrease the allowance by 2 million, then you'll see that it will be, oh, actually it's better to write it this way, and now copy the address of the spender, paste it over here, transact, and now let's check the allowance. As you can see, it's now 20 million. So that's how it works. That's when we decrease the allowance, we decrease the allowance for spending the money, and then once we increase the allowance, we increase the allowance of spending money by the spender. So that's the way we can transact and check the allowance. And as you can see, the balance of the spender is still 0. However, he or she is allowed to spend 20 million of the tokens. So we check the other different parameters, and also if you're familiar with the tokens and how they work, you're now familiar with the approval, the allowances, and also transfer and transfer from. So once you want to transfer, you can choose a specific address. So for example, I can choose the third address here, so to this address, and the amount is, for example, 1 million. So now we can transfer from the person who holds the tokens, right? So here I can click on the transaction. Now let's copy the address and check the balance of it. Control A, Control V, and balance is, as you can see, 1 million tokens. So, but if you want to spend using the address who has the capability of spending it, so who has been given the allowance, you should use the transfer from instead of transfer. So once I use the transfer from, so it's from the address of the owner of the contract, or the person who has given the allowance. So that person who gives the allowance doesn't need to be necessarily the person who has minted the token, but the message sender, or someone who holds a number of tokens as a balance in the balances. So right now I can transfer from the address of the first address, right? So I can copy it and paste it right over here from this address to one of the other addresses. So for example, the fourth address, copy and paste it right over here. Oh, it's right over here. So I can choose, for example, 5 million. And then the person who should sign the transaction is the second address, because he or she has been given the allowance for spending the tokens, not the first address, right? So this allowance has been given to that address. So let's transact, and as you can see, it's been done successfully. If you choose any other address for the message sender, then it won't work. So now if you check the address of to address, copy and paste it here, check the balance, as you can see, it's 5 million. So the money has been spent, and he or she has been given the allowance, right? So okay, so it's 5 million. Now you can check the balance of the first address. I can copy it and paste it somewhere here in balance of. As you can see, it's now been changed, and the total supply was a very big number. Now we've reduced some money for transfer and transfer from, so that's now why it's been changed. And notice that the gas fee is reduced from the Ethereum amount, Ethereum balance of the addresses, not from the tokens, right? So this is one thing to notice if you haven't considered it. So we've checked the transfer from allowance and increase and decrease allowance. We've also checked the approval, right, for one of the addresses. So that's how it works. We've checked all of the functions and all of the different variables. So just as easy as that, you can create a token. You can also customize it by adding some other parts to the smart contract. And with that said, that's it for this part of the tutorial. In the next ones, we'll work on other smart contracts.